Continuing with our investigation of section 4.4 from our calculus text, here's an important result that can be used to identify critical points as relative maxes or relative mins. We had the first derivative test in the previous section, and now we can actually use the second derivative as well to, most of the time, find whether we've got a local max or local min at a critical point. But one thing to be aware from the beginning, though, is that we're looking only in the case where the critical point arose because the derivative was equal to 0. We're ignoring the possibility of it being undefined in this particular test. And we're going to examine the sign of f double prime of c. And we're going to plug the critical number into the second derivative, and its sign is going to tell us something about the nature of the critical point. There are three possibilities when we do this. We either get a positive second derivative value, a negative second derivative value, or we get 0 out. So let's check and see what we've got here. The first case says that if the second derivative is positive at c, then we've got a local minimum. And so let's see why that's the case. So I've got a function which is concave up, and I've got a 0 first derivative. So it's going to be something possibly like this. So f prime of c is equal to 0. I'm concave up. And notice that I've got a local minimum here when that's the case. Another possibility is if I'm concave down at c and I've got a 0 derivative. So I could have something like this, roughly speaking. I've got a horizontal tangent line here, so f prime of c is still 0. And I'm concave down, this case. And notice I've got a local max. So to see why what's going on in case 3 is indeed the case, that if the second derivative is 0 as well as the first derivative, I can't really tell whether it's a max or a min. Let me look at two examples. The first one is going to be f of x equals x to the fourth. F prime is 4x cubed, and hopefully we can see that if I set the derivative equal to 0, I get that x equals 0. This is my critical point. And f double prime of 0, let's do f double prime of x first, calculate the second derivative. That's 12x squared. F double prime of 0 is equal to 0. So I'm in this case right here where the second derivative is 0 at the critical point. Well, let's look at the graph of this function. Very roughly speaking, I'm going to have something like this. It's going to come in, and it's very, very shallow right here. It levels off almost. This first and second derivatives are both positive. Notice that this is a local min. But I could also look at f of x equals minus x to the fourth. F prime is minus 4x cubed. 0 is still a critical point. The second derivative is minus 12x squared, and f double prime of 0 is 0 for this function as well. But this time, what does my graph look like? Oops, let's try a better set of axes here. My function this time is going to look something like this. And so I've got a local max. So I really can't tell whether I've got a max or a min when the second derivative is 0 as well as the first derivative being 0. So let's apply the second derivative test to a function down here. So again, remember, we're going to plug critical numbers in and see what the sign of the second derivative is. So my function h of x equals 3x to the fourth minus 8x cubed plus 6x squared. h prime 12x squared minus 12x cubed, 12x cubed minus 24x squared plus 12x. And notice that I can factor out a 12x from this. And when I do that, I get 12x times x squared minus 2x plus 1, and we want to recognize that x squared minus 2x plus 1 is x minus 1 quantity squared. So if I set h prime equal to 0, I get that x is equal to 0 or x minus 1 is equal to 0, which is x equal to 1. So 0 and 1 are my critical points. At this point, I calculate the second derivative. H double prime is going to be 36x squared minus 48x plus 12. And then I evaluate h double prime at my critical points and try to classify. H double prime of 0 is going to be equal to 12 when I put 0 in for x here and here. That's positive, and so that tells me that h of 0 equals 0 is a local minimum. So when the second derivative is positive, I have a local minimum. H double prime of 1, on the other hand, is going to be equal to 36 minus 48 plus 12. That's equal to 0. The test is inconclusive. So I can't tell whether I have a maximum or minimum, or actually I might not have either. And that's what we're going to see. That's what the case is here. So let's go back and look at the first derivative now. So let's look at the first derivative test to see what's going on at 1. So my critical numbers are 0 and 1. My derivative, we said, for h was 12x times x minus 1 squared. So I need a test point. So I'm going to choose 1/2 here and 2 here. I already know the story from the second derivative test at 0. So I'm just going to look at 1/2 and 2. H prime of 1/2 is going to be 12 times 1/2 times 1/2 minus 1 squared. That's a positive quantity. Whereas h prime of 2 is 12 times 2 times 2 minus 1 squared. That's also positive. So remember that this, even though it's negative inside, when I square it, it becomes positive. This is also positive. So I'm increasing here, and I'm increasing here. So what's going on is that this is neither a max nor a min.